So far we have learned up to side distance section. We got an introduction to road design, then we learned about the basic design criteria and then the cross section of a road, and finally the side distance criteria when designing roads. In this section, what we are going to do is look at the horizontal alignment of the road. So what is horizontal alignment? Horizontal alignment means the plan view of the road. So if you go to the sky and see the roads below, you can see only straights and curves on the road. So you cannot see any elevation of these roads. You will only see the straight sections and curved sections. So the horizontal alignment means the plan view of a road. It consists of straights and curves. So horizontal alignment design means we are maintaining an appropriate relationship between design speed, curvature, and we make another relationship between the side friction and super elevation. So we will be learning these things in the coming slides. So this is what happens when you go to Google Map. You can see the plan view of a road. This is a collection of roads. Only you can see is the straight sections and curved section of the road. So this is the horizontal alignment of the road. This is what we call horizontal alignment. Then, as I told you earlier, horizontal alignment consists of straights and curves. But we have some additional thing here. These tangents are called the straights, then the curves are the curves, and finally we have something called transitions. So in this image you can see this is a straight road. In the middle image you can see a curved road. So we call it a curved section of a road. This is a straight section of a road. So if you consider about the radius of a straight section, that is infinity. Then something like this, a curve, it might have a radius something like 1000 or 100 or 50, whatever. So it has some value for radius. So when you are going to change the radius from infinity to 1000, we can introduce a small curve which change the radius from infinity to 1000. In this section, the radius of the road changes from infinity to 1000. So we call it a transition curve. So we are using this transition curves in horizontal alignment design at lower speeds. As well as higher speeds also we are using that, but the major criteria is the radius of the road. If you have less radius for a road curve such as this, so if you are designing for a design speed of 100 kilometers per hour, if you have a 1000 radius curve, you might use a transition curve. Sometimes we don't need to use transition curves if this radius is high value. So that is about transition curves. Then we have some important things. Some curves require super elevation. So I will talk about super elevations in a later slide, but as for the sake of the completeness, I will tell what is super elevation here. Super elevation is the slope of the road. If you see in this image, the middle image, the slope of the road is completely to this side. So we call it the super elevation because the road is fully rotated to one side. Usually you see the roads as usually you see the roads rotated to two directions. That means at center line it comes like this and goes like this, two directions. But at a curve you have one direction slope. We call it super elevation. So this super elevation is used to counteract the effect of centrifugal force and to retard sliding and overturning and allow more uniform speed as well as for use of lesser land for road design. So we will be learning these things in later slides. So here I will describe what is meant by super elevation and what is happening when a car or a vehicle is driving on a circular road. So you may have learned this in your A levels in physics, movement along a circular path. So if you consider this car, it is coming inside this curve, so it will have a centrifugal force which acts outside which drags the vehicle outside of the curve. So that centrifugal force will drag this vehicle towards the outside edge of the curve. But you have the friction force acting inside direction to the curve, because if the vehicle is going to slide to this way or drag to this way, the super friction force will counteract that and it will act towards this side or the inside of the curve. Because of the inclination of this road, that means this super elevation, this inclination means super elevation. Because of this inclination, you have a component from the weight to inside of the curve. The vehicle weight is coming down, straight down, but some component will act into the inside section of the road. So the collection of this friction force and force due to inclination of road, these two will counteract this centrifugal force. So using the equation F equals half mv squared, you can derive an equation something like this: E plus F equals V squared 127 R. So E means the super elevation, as I told you, it is this inclination of the road. Then F is the coefficient of side friction between tire and road surface. That means when the vehicle is going to drag this way, the friction of the tire and road surface act along this way. So that friction is called the side friction. If you can remember, we learned about another friction factor called longitudinal friction factor, that is acting along the road. This one is acting across the road. So then we have the design speed of the road, and finally we have the radius of the curve. So we can see the movement along a circular path depends on these factors, especially V and R. If V is increasing, R should be decreased. So R should also be increased. So from this equation, E plus F equals V squared over 127R, we can get R as the subject and we can put all the things to the other side. So you have R at the left and all the things other side. So we can derive a minimum radius for a curve. So if you take the minimum radius, design speed for a road section is a constant value. So it depends on E and F, super elevation and side friction. So this R would be minimum when E is maximum and F is maximum. So we get the minimum radius when you have lowest maximum super elevation as well as maximum side friction. So now we will look at what is the maximum super elevation. So you cannot have as much as super elevation you like, because inclination of the road depends on several factors, or super elevation depends on several factors. What are these factors? One thing is terrain. Terrain means what kind of natural ground behavior you have in this area. If it is a flat terrain, that means you have a flat area. You don't have high variation of the road. So you call it a flat terrain. If it is a rolling terrain, you have flat as well as some mountainous type high sections in the road. If it is a mountainous terrain, you have a mountain to climb in that road section. You have a high steep slope in the road. So you call it mountainous terrain. So your super elevation depends on terrain type, flat, rolling or mountainous. Then type of area, that means whether it is a rural area or a urban area. For rural area we call them open areas, and urban areas we call them built up areas like here. So then frequency of slow moving vehicles who might be influenced by high super elevation rates. So what does this mean? This means slow moving vehicles, that implies for trucks or heavy vehicles, they are moving slowly. So if you have high super elevation rates and if you have so many slow moving vehicles, if you can remember that a component of the vehicle load acts inside direction or towards the center of the curve. So if I go back to this image, so if you have a heavy vehicle here, so this load will act on the ground and one component will act along the road. So if you have a high inclination, this load component will be high and it might cause the heavy vehicles to fall or topple on the road. You may have seen this in roads. Sometimes the heavy vehicles are fallen apart or they are toppled on the road because of this super elevation effect. So in this table is taken from RDA design guidelines. It will tell you if your road is in a flat terrain, and if it is an open area, that means if it is a rural area, you have to use maximum super elevation of 6%. So if you are trying to get the radius, you have to use, for a flat terrain, you have to use Emax of 6%. That does not mean you have to always select 6%, but the maximum is 6%. You can use less than that value, 6% or less than that value. Then for a rolling terrain, you can go up to 8%, and mountainous terrain, you can go up to 10%. So in the built-up areas, we always think that the highest super elevation is 6%, not more than that. Then the other factor, maximum site friction factor. In the equation it was Emax plus Fmax. So the maximum site friction factors are given in RDA design guidelines. So it depends on the design speed of the vehicle. So you can see these values depends on the design speed of the vehicles, the Fmax values. The bituminous surfaces are the surfaces, the asphalt surface or the tar roads. So those are the friction values for tar roads, and this is for gravel roads, which we are using in village roads. So these are the factors you have to use when calculating the minimum radius for a horizontal curve. So with these two parameters, we can define the recommended minimum curve radius for a road curve. That means something like this. If I consider this row, assume that you are assigned to design a road. So the design speed of the road is 30 kilometers per hour. Then you have to have let us say you have to have a road curve. You have to design a road curve. So now you are in a position to select the road curve. So when you draw the curve, when you draw the curve, you want to have an idea, you need to have an idea what kind of radius I have to use for this design speed. So if you design the road for 30 kilometers per hour, and if we assume that road is in an urban area, so maximum super elevation you can go is 6%. For maximum super elevation 6%, for design speed of 30, the lowest radius you can go is 30 meters for the road curve. So for your horizontal alignment, you cannot use curves where your radius is less than 30 meters for design speed of 30 in an urban area. So if you have a 25 meter radius, that can't be, so you have to increase the radius to 30 meters or more. It is okay to have radius, let us say 35 meters. Then it is okay because it is greater than 30. So that is the basis how to select the road curves. So for one more example, if we assume that we are going to design a road with 50 kilometers per hour, here 50 kilometers per hour, let us say that is an urban area as well. So you can have maximum super elevation of 6%. So you have this row and this row. So the lowest radius you can take is 90 meters. So whatever the radius you apply to a curve in your road should be 90 or greater than that. So if there's a situation you can't adopt 90 meter radius at some location, there are some certain precautions we can get, but generally you have to use a radius which is greater than 90 meter when you are designing a design speed of 50 kilometers per hour. So that is about minimum radius of curves. You have to select the minimum radius and depending on the design speed and depending on other scenarios. We learned about the maximum super elevation. So what is the minimum super elevation you can have? We learned about maximum super elevation. What is the minimum super elevation we can have? So what are the criteria we need to consider when you think of the minimum super elevation? The minimum super elevation is used to cater the drainage requirement. So when you are constructing a road, you need to ensure that no water is retained inside the road when it is raining or when it is a wet season or a wet condition. The water which comes on top of the road should have to be drained out from the road. It cannot be retained, or it cannot be stored, or it cannot be stayed on the road until it is dried out. So we need to make sure that there is no water retained on the road when it is raining or when the road is at a wet condition. So the minimum super elevation is selected to cater the drainage requirement. In Sri Lanka, the minimum super elevation is minus 2.5. Minimum super elevation means you might have, you can actually when the vehicle is driving on a curve, we learn that to counteract the centrifugal force we need super elevation, but on a straight section we don't need super elevation. So that means we can have a flat road, but if you have a flat road, it will not drain out the water from road. So in straight section especially, to drain out the water from the road surface, we use a inclination to the road, so we call it the normal crossfall. It is minus 2.5 for each direction of the road. If this is the center line of the road, it will slope down minus 2.5 slope. So that is the general practice in Sri Lanka. But this minus 2.5 value or this normal crossfall is changed from country to country depending on their design guidelines. In USA they might usually use minus 2. In Australia they use minus 3. So in Sri Lanka what we use is minus 2.5. Then we are looking at the concept called adverse crossfall. So what is adverse crossfall? So to describe this, I will go back to the slide where we learned about motion along a circular path. So in this slide we see the inclination of the road and the friction force will counteract the centrifugal force. So the inclination of the road or otherwise the super elevation of the road will depend on the radius of that curve. If the curve radius is high, you might not have higher super elevation. If the curve radius is lower, you should have higher super elevation. So if this radius is high, that means you don't need much super elevation. So when this radius is high, the curve radius is high, this friction force can single-handedly tackle this centrifugal force. He does not need the force due to inclination of the road. So that means the curve does not need super elevation at this curve radius. So at that radius, that means at a higher radius, this super elevation or the inclination of road will not be used to counteract the centrifugal force. The friction force itself counteracts the centrifugal force. So that means you don't need to incline this road. So you don't need to incline this road. Instead, you can use the normal crossfall at that section. So usually at a curve, in this curve, your road is sloped like this. But at a higher radius, if this friction force single-handedly counteracts this centrifugal force, you can have this road like this, slope two ways. So you call that radius adverse crossfall. You call that radius adverse crossfall. This adverse crossfall means at that cross radius, your road has a normal crossfall. It don't have a super elevation. It will only have a normal crossfall. So to have the adverse crossfall, we select the side friction values as 0.06 and 0.07. For open areas 0.06, that means F max, and for built up areas it is 0.07. So when you calculate the radius would come, if the design speed is 30, the adverse crossfall for an open area would be 205, for a built up area it would be 160. So if your curve is 205, you don't need to have super elevation. So if I make it more clear, if you have a radius of 100 meters, you should have super elevation of 2.5, because if the design speed is 30 and your radius is 100 meters, that means more than 35, you should have super elevation of 2.5. So when your radius is more than the adverse crossfall or equal to adverse crossfall, your super elevation will not be there. Your super elevation would be the normal crossfall. So there won't be any super elevation. That super elevation would be replaced by the normal crossfall. So we will be learning it more clearly when we are learning about super elevation section. But for the moment, you have to understand if your curve radius is greater than the adverse crossfall, you have to use normal crossfall for the rho. That's about adverse crossfall. Then we will learn about the types of horizontal curves. We have several types of curves: circular curves, transition curves, reverse curves, and unidirectional curves. Circular curves are simple curves. Transition curves, I told you earlier, they are the radius changing from infinity to some definite value. Yeah, like in the first slide I told you about changing the radius from infinity to 1000, like that. Reverse curves and unidirectional curves are type of curves where you have two curves in same direction or two curves in different directions. So we will be learning them here. This is a simple curve. You have a curve on the road. We call it a simple curve. Then unidirectional curve means you have two curves in the same direction. Sometimes there may be a small straight section in the middle. Sometimes there won't be a straight section. You have two curves, two radius of curves on the road. So if you have a small tangent section or a straight section, we call it a broken back curve. Otherwise, we call this a compound curve. So in reverse curves, you have a curve coming from one direction and changing its direction to the other side. There may be a small tangent in between. So this is a reverse curve with tangent, and this is a reverse curve without tangent. So if I see this image, you can see here I have a curve going this direction, and I have another curve in the same direction with a small straight section in the middle. So we call this a broken back curve. You have a curve in the same direction, you have another curve with a straight section in the middle. So if you don't have this straight section, only these two curves, you call it a unidirectional curve. In here you can see this curve is coming this direction and it is changing the direction to the other side. You call it a reverse curve. Coming from this side and change the direction to the other side. So this section you have a reverse curve, in this section you have a compound curve. So that is about horizontal alignment. We learned about the horizontal alignment. What are the curves, what are the straights, what are the transition sections, and we learned about super elevation, and we learned about the radius of curves, what are the minimum radius of curves we have to adopt, and then we learned about maximum super elevation and minimum super elevation where we have to use in urban conditions and rural conditions, and then we talked about the minimum super elevations where we have to cater the drainage requirement, and finally we learned about the adverse crossfall where you don't need super elevation at a curve because at adverse crossfall the super elevation itself counteracts the centrifugal force. Then finally we learned about the various types of horizontal curves we have: simple curves, unidirectional curves, reverse curves, and the transition curves. So in the next section we will be looking at the super elevation, one of the hardest and important criteria, important section in highway geometric design. So we will be looking at that in the next section.